Hello, in this video we're going to learn how to draw a molecule by drawing the Lewis and VSEPR diagrams, determining the electron groups, shape, labeling the angles, and discussing the repulsion between the electron groups and how it affects the shape and angles of our molecule. So let's get started. So we are going to be working with oxygen difluoride, which is OF2. And we should first determine the number of valence electrons. So in this case we have 6 valence electrons for oxygen and 14 valence electrons for fluorine, which equals 20 valence electrons or 10 electron pairs. First, we also need to determine the number of electron groups in our molecule. One way to do that is to simply draw the Lewis dot structure, which we're going to go ahead and do that right now in pink. So we have oxygen in the center, we have fluorine on the sides, which equal 16 valence electrons. To make 20 valence electrons, we will need 4 more electrons, which will equal to 2 lone pairs. Due to the fact that oxygen has 2 lone pairs, it will cause a bent shape in the molecule, so it will affect the way we will draw the Lewis dot structure diagram. So we're going to go ahead and bend the atoms right here. However, that still does not give the best representation of the 3D shape of the molecule. So after we determine the number of electron groups, which in this case is 2 electron groups and 2 lone pairs, let's go ahead and draw the VSEPR diagram in white. So you have one fluorine on here and the other fluorine on the other side, and we're going to go ahead and represent that in a wedge as it's coming towards you, and the 2 lone pairs. So here we have 2 images of our molecule, in which the image on the left represents the Lewis dot diagram because it does not include the 2 lone pairs that the molecule has, and on the other side the image represents best the molecule because it does show the 2 lone pairs for this molecule. Here it is important to know that the 2 lone pairs do have an effect on the shape and the angles of this molecule, as well as the bonding pairs, which is 2. And that will be how you would determine the shape of this molecule. Thank you.